to be or not to be? That is the question.
Are we, mankind, something unique on this planet and in this universe? Or are we just another beast? That is the question, which, given the recent events in Japan and around the Pacific Rim of Fire, now, more than ever, is the existential question. Were we to continue to act as those duped monetarist followers of Adam Smith would demand, as mere Darwinian creatures in a fit of survival, pursuing the greatest pleasure while avoiding pain, with one side of this false dichotomy declaring that the few should be free to maximize their pleasure, while the other side pleads that we must set rules to minimize the pain of the many, then, as beasts, we are destined to suffer the same fate as all animals who have ever preceded or shall ever follow us. For as we know, nearly 99% of all species that have ever existed on this planet have gone extinct. But if we recognize that to man is granted a higher identity, above the simple perceptions of our mere mortal coil, an identity consistent with the greatest achievements of classical art and science, then we must locate our mission not in what is, but in what must become. To better understand what paths lie before us, we must turn to the stars, not as astrologers or simple stargazers, but as a kind of galactic archaeologist, to see how the unfolding of galactic and extragalactic processes have become manifest here on Earth, as a way of gaining insight into what has occurred in the past and to understand potentially what lies ahead in the future. We start with what has been discovered as a roughly 62 million year cycle in the record of marine biodiversity, as compiled by John Sepkowski and David Raup, which goes back roughly 542 million years, spanning the period known as the Phanerozoic. From that biodiversity record, it was found, by a group led by Robert Mueller, that the trend of biodiversity, measured as the number of different genera of creatures, goes through a cycle of increase and decrease every 62 million years, though neither a cause for this cycle nor a correlation to other processes could be found by that group. It was left to astrophysicist Milutin Medvedev out of the University of Kansas to hypothesize that this 62 million year cycle in biodiversity was connected to the theorized roughly 60 million year cycle of our solar system's bobbing up and down through the plane of the galaxy as it orbits the center of the Milky Way. Now, a discrepancy for those that had previously attempted to make a connection between the 62 million year biodiversity cycle and the movement of our solar system through the galaxy was that the singular moments in the movement of our solar system seemed to occur at roughly 30 million year intervals, either as points of maximal distance from the galactic plane on either the northern or the southern side of the galactic plane, or at crossing points of the plane, all of which occur at 30 million year intervals. So why the 62 million year cycle and not the 30? What Milutin et al. Proposed was that this 62 million year cycle was connected to the movement of our solar system towards the northern side of the galaxy exclusively, because this northern side was the direction of movement of our galaxy towards a large cluster of other galaxies known as the Virgo cluster, located in the Virgo constellation, as seen from our vantage point here on Earth. The idea being that as our galaxy moves at the estimated 200 kilometers a second into the dense electromagnetic cosmic environment, a kind of shock front is generated, which in effect concentrates and amplifies various forms of cosmic radiation towards the northern side of our galaxy. And that as our solar system bobbed towards that northern side of the Milky Way, it would experience an intensification of cosmic radiation. Now, they viewed the relevance of this cosmic ray increase somewhat simplistically, as a kinematic driver of biodiversification. But what will become clear as we proceed is that there is a much more dynamic set of processes associated with this cycle, which cannot be reduced to simple mechanistic causes. Now, this model just discussed isn't the only hypothesis of its type. Consistent with this idea of the increase in cosmic ray intensification as a function of galactic cycles and a driver of processes here on Earth is the work of scientists near Shaviv and others, who looked at the geological record to determine the cycle of increase of cosmic ray exposure on Earth. They determined this cycle from the potassium 40 and 41 isotope ratios measured in iron-nickel meteorites found on Earth, and correlated this to the increase of cosmic rays suspected to occur with the passage of our solar system through the spiral arms of the Milky Way galaxy, which they calculated to occur roughly every 143 million years. The idea being that cosmic ray intensity is greatest in the galactic arms, which are composed of packed clusters of stars and which have a much higher frequency of star bursts and supernova events, which, simply put, can be thought of as events of stellar expansion at star birth and the source of high-energy cosmic radiation. Now, there is something more sinister lurking in those 62 million-year cycles of biodiversity increase and decrease as our solar system bobs up and down through the galactic plane. There is a clear correlation between the galactic cycle and the mass extinction events on Earth, with what are known as the Big Five Extinctions, all occurring in the same general zone of the 62 million-year cycle and with the same direction of movement of the solar system relative to the galactic plane. Also, 4 of those Big Five extinctions line up with the periods of increased cosmic radiation associated with the 143 million-year cycle of movement of the solar system through the galactic arms. And so, there is a clear coincidence of our solar system's movement through the galaxy and major extinction events, which should lead the living and the thinking to ask, where is our solar system situated within the galactic cycles today? As it is, current estimates indicate that our solar system is currently 30 light years above the galactic plane on the northern side of the galaxy, in roughly that same general space-time location and with the same trajectory which coincides with those major extinction periods of our past. In other words, our current relativistic position in the galaxy is in phase with position and direction of movement that coincides with the major extinction events of the past. Now, those who are well versed in the biological and geological history of our planet might retort, you are simply making correlations that relate galactic cycles and cosmic ray increases to biodiversity changes and extinctions. But this is pure chance coincidence, for we know what caused the great extinctions, and that these causes are, for the most part, Earth-centric, geological and climatological forces, and are by no means related to each other, nor are they galactic in nature. Well, let's investigate. So, to refresh our memories and to lay the foundation for the case of the cosmic rays, let's look at what is commonly known about the Big Five extinctions, just to hone in on that which has been best studied and which is most dramatic in the history of life on our planet. Those extinctions are as follows. Starting from the most recent of the Big Five mass extinctions, the one which began 65 million years ago and wiped out 50% of all genera on the planet, is known as the KT extinction, because it demarcates the boundary between the Cretaceous and the Tertiary, and is most well known because it brought about the elimination of the dinosaurs. The best analysis suggests that this was brought about by the combination of 2 factors. First, the impact of a massive asteroid whose crater is located partially on the upper part of the Yucatan Peninsula in Mexico, which, though is of cosmic origin, is neither a periodic phenomenon nor one commonly associated with cosmic radiation. And the second extinction cause is tectonic movement and supercontinental breakup, coupled with the massive sequence of eruptions of the Deccan Traps, a volcanic region in western India whose initial eruption phase spewed forth lava flows covering 1.5 million square kilometers of surface area, roughly half the size of India, and brought forth massive amounts of deep earth gases. The next extinction, going back in time 200 million years, occurred at the end of the Triassic and eliminated 48% of all genera and is thought to have been driven by the eruption of the Central Atlantic Magmatic Province, which constitute a massive eruption of lava to the surface associated with the continental breakup of Pangaea, and covered over 11 million square kilometers of land in lava, and brought forth all kinds of climate-altering gases. At 250 million years ago, the most anomalous of all extinctions happened, known as the end Permian, in which 83% of all genera of creatures were wiped out, 96% in the sea, and 70% of land vertebrae. This mass annihilation of life is generally associated with effects stemming from the mass volcanic eruption of the Siberian Traps, the crustal disturbances connected with the formation of the supercontinent Pangaea. Next, coming 370 million years ago, is the late Devonian extinction, which saw 50% of all genera and 70% of all species killed off, and is thought to have resulted from a major deep freeze of the entire globe. And finally, the oldest of the Big Five, occurring 445 million years ago, known as the late Ordovician, saw 57% of all genera killed off, and is thought to have been brought about by the intensive plate tectonics with accompanying ocean level changes. So, from this generally accepted notion of the events and drivers associated with the Big Five extinctions, one might feel justified in saying that these extinctions are all driven by very different causes, from volcanic activity to tectonic movements and continental shifts, to rapid cooling periods and ice ages, to asteroid hits, and that these have no relation to each other, let alone to cosmic radiation and galactic processes. But a look beyond the shadowy world of the high priests of academia and accepted pop science reveals a slew of forefront research that links all of these various causes associated with extinctions to galactic cycles and varying forms of cosmic radiation. Let me mention just a few of the frontiers in research that make the point. In India, where the ability to predict earthquakes is at a premium, Dr. Mukherjee, head of the Geology and Remote Sensing Applications School of Environmental Sciences at Nehru University in New Delhi, for the purpose of developing earthquake early warning systems, is looking at the correlation between earthquakes and changes in the cosmic ray flux and changes in Earth's magnetic field. He is looking at 1, the way changes in the sun, as manifest in coronal mass ejections, for example, can trigger changes in the electromagnetic environment of the Earth, leading to such things as earthquakes and rapid temperature changes and increased snowfall. And 2, the correlations of these changes in the Sun, Earth, electromagnetic environment to galactic and extragalactic starbursts, which are intense star flare-ups that can cause changes to the magnetic field of the Sun and increase the flux of cosmic rays. And it is this rapid increase in cosmic radiation which he has shown to be correlated with earthquake activity and dramatic weather changes. This work is consistent with that of the famed Danish astrophysicist Heinrich Svensmark, who, based off of his own work and building on the work of others, such as astronomer Nir Shaviv, has developed a theory showing a causal connection between increased cosmic ray flux and global cooling, while drawing correlations between that increase in the cosmic ray flux with movements through the arms of the spiral galaxy, as well as correlating the episodic massive increases in cosmic ray intensity with local starbursts and supernova events, which are potentially triggered by our galaxy's interaction with nearby extragalactic structures, such as the Large Magellanic Cloud, as well as our solar system's current excursion inside what's known as Gold's Belt, a region in our galaxy of concentrated star formation and supernova activity. Similarly, Yu Zhendong of the Hubei Research Institute of Environmental Protection in Wuhan, China, has written a paper called Strong Earthquake, Nova, and Cosmic Ray Environment, which takes data going back to the 1930s and looks at intervals of increased earthquake activity, which he characterized as 10 or more earthquakes of magnitude 7.0 or greater in a 2-month period, and correlates that with observed nova flare-ups. He has more recently written a paper relating the massive 8.0 earthquake of 2005, centered in Wenchuan, China, to a sharp spike in ground-level cosmic ray intensity prior to the quake, and draws similar correlations to 8 other large earthquakes in China over the last 100 years. Along similar lines, a group of Japanese scientists have released a paper titled "Explosive Volcanic Eruptions Triggered by Cosmic Rays," in which they correlate violent volcanic eruptions in Japan over the last 300 years with a period of increased cosmic radiation, which they see as related to the activity of the Sun. That is, periods of minimal activity of the Sun correlate with periods of intensification of galactic and extragalactic cosmic radiation, due to the fact that a more active Sun will provide a greater shielding to the Earth, whereas a less active Sun will allow more cosmic radiation to pass to the Earth environment, leading to greater volcanic activity. They hypothesized that the mechanism for this would be a cosmic radiation-induced nucleation process in specifically silicon-rich magma, triggering the eruption. This is consistent with the earlier mentioned work of Svensmark on the relation of the Sun-Earth cosmic radiation environment to global weather. But more to this point of the relationship of cosmic radiation to volcanic activity and magma upwellings in the oceans and on the continents. There's a group out of Canada who did an analysis of a number of what are known as large igneous rock providences, which are large areas where upwelling magma has cooled into rock, such as in the previously mentioned Deakin and Siberian traps. They date these large igneous rock providences back as far as 3.5 billion years. What they found were a number of different multi-million-year cycles in their rate of occurrence. In particular, they identified a roughly 170 million-year cycle spanning a time from 1.6 billion years ago to the present, and a scattering of different roughly 60 million-year cycles distributed in interval clusters throughout the 3.5 billion-year record. These cycles should, of course, draw our attention back to the 62 million and roughly 143 million-year cycle associated with the movement of our solar system through the galaxy. To bring even stronger support to the relationship of galactic cycles to massive crustal disturbances and related processes, that same group of Malott and friends, who drew the correlation of biodiversity changes to the 62 million-year cycle of our solar system's movement through the galaxy, also found a nearly 62 million-year cycle in the rise of the chemical isotope strontium, which they associate with seafloor spreading, tectonic activity, and continental uplift, where increase in the ratio of strontium-87 to 86 rises proportionally to decrease in biodiversity, which consequently, according to the hypothesis, correlates increased cosmic radiation flux to increased seafloor spreading and continental uplift. Thus we see, from the foregoing, that all those processes thought to be drivers of extinctions on the planet, from tectonic activity and continental shifts, to volcanoes and related magma plumes and lava flows, to ice ages, can all be correlated to the large cycles relating our solar system to the galaxy. In particular, the 62 million-year and 143 million-year cycle, with emphasis on the role of cosmic radiation as the invariant driver of these various processes. Which raises the question, what actually causes what? So, with what has just been discussed in mind, let us now again look at where our solar system, and consequently our Earth, are relative to those galactic cycles. As you can see, we are currently in the same zone of the 62 million-year biodiversity cycle and the theorized 60 million-year cycle of galactic bobbing, which corresponds with those phases of the cycle in which the Big Five extinctions discussed above correlate. More specifically, it's been calculated that we are about 30 light-years north of the galactic plane, having crossed the galactic plane roughly 3 million years ago, and are traveling in the direction of the northern side of the galactic plane, which is the side of that has been theorized to be subject to intensified cosmic radiation flux due to the cosmic ray accelerating shock front created by the movement of our galaxy in the direction towards the extragalactic Virgo cluster. So, as you see, the Big Five extinctions have all occurred in the phase of the biodiversity cycle theorized to correspond to the movement of the solar system towards the northern side of the galaxy. Also, relative to the spiral arms, we have been, for the past several million years, in what is called the Orion Arm, an offshoot of the major galactic arm known as the Sagittarius Carina, which is relevant because, as has been determined by Svensmark, the star density in the arms is 80% greater than between them, and it has been calculated that our position in the arms has a 10 times greater influence on the cosmic ray flux density than that which is determined by the smaller changing influence of the Sun. But is this the whole story? Is it the case that the Earth and life on it are simply left to be bashed and battered around by the forces of the galaxy, hoping that enough survives each of these episodic disasters to keep some semblance of continuity? Can we locate any overall reason or intention in this process? Or is life just caught in some repetitive cycle of effects, waiting ultimately for either an explosion of our Sun or a collision of our Milky Way with a nearby galaxy, both of which are said to occur in roughly 5 billion years, a relatively short period of time from the vantage point of extragalactic processes? To get above the question, so to speak, and beyond the simplistic reading of the history of our planet in the galaxy as merely one in which a series of cyclical changes at the galactic level correlate with changes in biodiversity punctuated by extinctions, we must recognize that this picture of the cycles is just one projection, and what must come to be understood as a multi-phase space universe of the Riemann-Vernadskian type, in which the willfully creative, the living, and the ostensibly non-living coexist as a nested set of hierarchical domains, each with its own characteristic space-time qualities, all of which are subsumed by what we might characterize as universal creativity or universal anti-entropy. We see this characterization of different space-times for different phase spaces when what from one type of measurement or analysis projects as cyclical and periodic, from another vantage point is in fact a steadily increasing process of growth, as we see when we look at the overall curve of biodiversity, which, though it has a periodicity, which has been theorized to be correlated to the periodic movement through the galaxy, clearly is one characterized by a subsumed growth function. But even this growth curve can be thought of as just a mean projection between two phase spaces, for the actual history of the biosphere as a whole is one characterized by nonlinear jumps from lower levels of organization and complexity to successively higher ones. In fact, these evolutionary jumps to higher states of organization seem to be coincident with periods coming out of what have otherwise been characterized as extinction phases. In other words, periods in the galactic cycle which were punctuated by extinctions also demarcate points of explosion in the upwardly developed power of life to act on the planet, with each phase of development laying the platform for the next higher state of the biosphere. For example, it was in the wake of the late Ordovician extinction that you saw the first movement of plant life out of the oceans and onto land, which of course revolutionized the biosphere of the Earth and created a whole new electromagnetic potential for the planet. For it was moving plant life onto land that cloud formation and sustained weather systems became possible. And along with the obvious water capture and weathering effects this has on the continents, this also facilitated the creation of the global electric circuit as we know it today, whose generated 10 to 30 Hertz range Schumann resonances play a regulatory role in such things as brain functions. And it was in the period coming out of the next subsequent extinction, the late Devonian extinction, that amphibians and then reptiles first evolved, representing the first colonization of land by vertebrate creatures, a biological revolution in itself. This meant that the biosphere now had a capability for relatively long-range directed movement and concentration of biogenic materials and organisms across the land. This is typified by such effects as the role of these creatures in spreading seeds and bacteria through their consumption and secretion, increasing the range and rate of expansion of the biosphere as a whole. In both the cases just mentioned, the movement of plants and then animals onto land, it meant life required the development of higher order, more complex structures, such as lungs, skins, and advanced vascular systems, capable of maintaining such things as internal hydration, as well as developing advanced capabilities for nutrition and energy acquisition, all of which take on a much higher level of difficulty on land than when in the more passive and buoyant environment of the seas and oceans. Much of this capability was achieved, as we've just alluded to, by symbiotic relationships or cooperation between different species and even whole kingdoms of life, representing the movement of life towards ever higher levels of complexity and specialization. As for example, in the relationship between the fungal kingdom and the plant kingdom, each of whose survival depends on exchange of nutrients between the two. Other such revolutions of successively higher order qualitative jumps in the evolution of life occurred in the midst of the next great extinctions as well, setting down successive higher order platforms and ultimately laying the foundation for one of the most robust explosions in the history of life, that which emerged out of the extinction of the dinosaurs, with the radiant takeover of the planet by the highly diversified and complex mammals, a creature whose high metabolism, roughly 10 times that of the dinosaurs, and highly regulated internal temperature give it a greater range of activity and capability to exist in much more diverse and changing climates, witnessed by the fact that you find varying mammals from the North Pole to the equator. But to achieve this, the mammals required a much higher energy source dense of food, which they found in the newly evolved grasses and the energy-rich fruit-bearing plants, the angiosperms, which had come to dominate the flora content of the planet, pushing aside the less developed and primitive gymnosperms. It is the relationship between these two, along with other relationships which will be elaborated at another time, that came to dominate the planet, pushing life into increasingly varied climates and increasing the overall intensity of flow of biogenic material through the planet. All this to the effect of shaping the biosphere of Earth to have conditions suitable for the prosperous emergence of mankind in the solar system, at a timing between 2 to 3 million years ago, which seems to coincide with the last crossing of our planet through the galactic plane as we move into phase with the already much discussed current inflection point of the 62 million year cycle. So again, just to emphasize the point, when we look to measure our galaxy, for example, from the perspective of how it's manifest in the phase space of life, measured in terms of its inherent characteristics, we get a picture of a process which is ontologically nonlinear and anti-entropic, such that what from one type of measurement may project as a roughly 62 million year or 143 million year cycle, from a higher phase space projects as a process that goes through long wave evolutionary upshifts. So why assume that the cyclical process is primary and the other developing process is just an epiphenomenon? This intersects another question that comes to the fore, which we alluded to earlier as regards the phenomenon of cosmic radiation, which has thus far been implicated as the driver of those effects associated with processes correlated to the large galactic and extragalactic cycles. Thus, in light of what was just discussed about the upward anti-entropic development of life on Earth, the question becomes, is there something deeper to the phenomenon of what we've come to call cosmic radiation than simply those kinematic and inherently destructive effects, as is typically the focus of those researchers who even dare to touch the subject? Fortunately, myself and others of the LaRouche Basement research team are in a unique position to approach this most profound subject because of an epistemological disposition which has led us to combine the research in galactic processes, as discussed thus far, with the work of biogeochemist Vladimir Vernadsky and biologist Alexander Gurvich, along with others who represent their scientific revolution. In brief, what Gurvich had discovered was that the internal processes of living organisms, such as growth, cell differentiation, and internal regulation, are mediated and controlled by what he called mitogenic radiation, which is internally generated bioradiation, whose source he determined was DNA and was measured in the ultraviolet range. Gurvitz saw this radiation as intimately connected to what he discovered as the unique biological field, which he thought of as a biological analog of Einstein's relativistic gravitational field. Subsequent work by Fritz Popp and a number of others have found bioradiation effects covering the whole range of the electromagnetic spectrum, and also found that the regulative effects are not simply limited to the internal workings of single organisms, but extend between organisms. And in fact, I would maintain that the entire biosphere of Vernadsky can be thought of as a highly complex bioradiant field, intimately connected to the broader domain of galactic and extragalactic cosmic radiation. So it is from this standpoint of the integrated cosmic radiation field and the correlation of processes here on Earth to galactic and extragalactic cycles that the evolutionary history of our planet must be investigated. Therefore, we must ask, how should we understand such periods in our galaxy's history of hyper-increase in star formation, such as the star birth period, whose effects are recorded to have impacted Earth 2 to 2.5 billion years ago, which timing correlates with the explosion of oxygen-producing life on Earth, whose atmospheric and biological consequences fundamentally revolutionized the nature of our planet. Or the period between 2 to 3 million years ago, which saw the emergence of man, and is a period in which at least one nearby supernova occurred, with tremendous secondary evidence pointing to the existence of at least one other. This is a period accompanied by rapid cooling and the greatest rate of fluctuation in temperature ever recorded, which is thought to be induced by cosmic radiation increases. Also at that time, the Earth saw the formation of the Isthmus of Panama, which connected North and South America and permanently changed the flow of the ocean currents, which in turn changed the electromagnetic characteristics of the planet, and whose formation is a result of tectonic activity and volcanic eruptions, which, as has been developed earlier, may also be correlated to cosmic radiation flux increases. And it is at roughly that time of 3 million years ago that we were to have been at the crossing points of the galactic plane as we started our ascent up towards the northern side of our galaxy. So evidence does point to the fact that man emerged in a period of terrestrial and galactic transformation correlated with cosmic radiation upshifts. All of which has the bearing on the question of the Crab Nebula, the most anomalous and energy-intensive astronomical entity known to astronomers, both in our galaxy and beyond, and whose birth was witnessed here on Earth just shy of 1,000 years ago in the year 1054 AD. Which brings us back to the real question. Where do we go now? Pause and reflect on the fact that we have not simply located ourselves in a process on Earth and in the galaxy, but have, in reality, to the extent of our current understanding, encompassed the whole process of evolution and galactic change as a one in our minds, something which no individual animal is capable of. That though, as a whole, the biosphere demonstrates a process of anti-entropic development, no individual animal in the biosphere is capable of being self-conscious of that process as a one, let alone creatively intervening to change the universe's level of development. That is something unique to the human creative individual, exemplified by scientific discovery, mediated and fostered through the unique domain of history and culture. And if mankind continues to ask the right questions and pose the right paradoxes, we may find that as mankind, we not only can better understand the processes of our galaxy and beyond, but one day may learn to control and harness them to our own fruitful benefit, as part of the ever-developing relationship of man to the universe. Thus, with this insight, we find creative man as not simply something in the universe, passively acted on by it, but rather we come to embody that principle of creativity which bounds our galaxy and the universe alike. And to that end, we say our future lies not in the stars, but rather the future of the stars lies in us.